So the topic for this particular video will be single responsibility principle. And this is one of the principles among 5 principles that we will be talking about. The 5 principles collectively are known as solid principles, which is very important when it comes to system design or low level design. Now this first one is single responsibility principle that represents the S in the solid principle. Got it? First thing, hey, what is the definition of SRP or single responsibility principle? Let's understand that. A class should have only one reason to change. Should have only one reason to change. That is the definition of single responsibility principle. This means that the class should have only one job, one responsibility, and one purpose. Like you cannot be doing a lot of things inside the class. That is not recommended. You can do it, but that doesn't align with the solid principles of system design. Understood? If a class takes more than one responsibility, then the responsibility becomes coupled. What does that mean? Basically, if you're having a lot of logic in a single class, it means you're kind of intersecting to different arenas. Changing one particular logic might impact the other and vice versa. So it's very important that you align one responsibility to a single class, and that is what determines SRP or single responsibility principle, because changes to one might break the other. Understood the definition? So that was the definition. It's very straightforward. A class should have one responsibility, one job, and one purpose. Straightforward. Let's understand with a real life analogy. We're talking about a restaurant, right? Now a restaurant has a lot of things, right? A restaurant will have a bunch of waiters, chef, someone at the reception, maybe security. Everyone has a different job, right? Someone like a waiter will be taking your order, delivering the food to your table, serving you whenever needed. Someone like a chef will be behind the doors, cooking whatever you will be ordering, and so on. Someone like someone at the reception will be, inviting the guest to the table and taking care while you enter. Someone at the security will be making sure that everything is in order. Now imagine if I take a single person, and I'll ask him, hey, can you be the waiter? Can you be the chef? Can you be at the reception? And can you be the security at the same time? That's not possible, because then it will misalign with his functionalities and he will not be able to perform well. So that is the definition of single responsibility principle. With a single class, I cannot assign it more than one responsibilities. Got it? Perfect. So we have kind of related SRP with a real life analogy. Now, why does SRP matter? Let's understand. I'll take an example of TUF Plus compiler, the code compiler where you write your code, where you run it, where you submit it, right? Now, on a very high level, you might think, okay, whenever I click the run or submit button, the code is getting executed and I'm getting the output. Pretty simple, but that's on a very high level point of view. But when I'm getting into the low level perspective now, there's a lot of things. Let's understand how does a compiler work. So as of now, you just write the boilerplate code. That means just the function. You don't write the main method, do you? You don't, right? So typically, behind our compiler, we have a lot of things that we need to do. We need to make sure that we add the driver code, that is the main method, and anything else that is required in order to execute your code that you have written. Okay, we need to make sure that syntactically it is correct. After that, we need to add test cases and we need to make your code run along with all the test cases that we have behind the wall. After that, whatever output we get for that submission ID, I'll have to store it in the database. After that, whatever is required, I'll be returning the necessary things. I don't need to return everything that the compiler has given me. I just need to return possibly the output, the runtime, the memory time. That's it. Everything else I can dump apart. Now imagine I have a single class that adds the driver code, that checks for the syntax, that adds the test case and runs it, that stores the output in the database, basically makes a database call and puts everything there, and then returns the response. This is not ideal, because imagine tomorrow if something breaks, you're not aware what is breaking. You'll have to typically check this, then this, then this, then this, and then this. It's gonna be messy. Why? Because you have tightly coupled everything with each other by putting them into a same class. Imagine you have a class, you have plus compiler, and then inside that you have a run method where you have everything listed. That's gonna be a lot of lines of code in a single class, in a single method. Maybe you can break the method down into different methods, but still it is under a same class. Now this is where you'll have to follow single responsibility principle, and you'll have to separate responsibilities. What you could do is you could have a class that deals with adding the driver code. Done. So one responsibility given to one class. You can have one more class which checks for the syntax and returns accordingly. If it is not correct, it will return an error message. You can have one more class that is going to, extract the test cases from the database, run your code against it. You can have one more class that's going to store the output in the database. You can have one more class which kind of, takes out the necessary things from the output that the compiler gave you. So you can typically have 5 classes with 5 responsibilities. Once you have 5 standalone classes, what you could do is you can coordinate by writing a single class that kind of calls them, or something similar. First, it will call this particular class, then this one, then this one, then this one, and then this one. So typically, you can have a coordinator that coordinates all of these modules or all of these classes. That's it. I could literally have class, compile or, run, whatever you want to call. And inside that, if I have a method run, it's first going to call add driver code class, then the syntax class, then the code run class, then the store output class, then get the response class, and that's it. So there will never be an error over here because it is just calling classes. And afterwards, in this particular class, you can have a try catch block. In this particular class, you can have a try catch block. Now imagine all of these code in a single class with so many try catch blocks. It's going to be messy, isn't it? It's going to be very tough to read through it. That is why you should be following single responsibility principle. Is it like a mandatory thing to do? Again, it's your call. It's something that's going to make your code more robust, more scalable, more maintainable, and at the same time more reliable. So I'll leave that to you. So I hope you understand why does single responsibility principle matters. And the next one, what are the benefits of single responsibility principle if I determine or if I decide that I'm going to do it? First of all, as I stated, it's going to improve maintainability. Tomorrow, if I have to, fix any portion of the code, tomorrow, if I have to add anything, and I can easily do it. So imagine tomorrow I come across and say that, hey, can you just add one more language check? Like, let's say I'm going to add something like a Kotlin. Now, I know that this particular class is running the code. So I'll go over there and maybe I'll write a condition for Kotlin. Or maybe I can have separate classes for C++, Java, Python, Kotlin, and so on. So I can extend my design depending on the use case. So it helps me to, increase maintainability. If everything was under one class, I'll have to figure out, okay, where was the change? And then eventually I'll have to do the change. So it becomes complicated to maintain the code. Next one, better test coverage. So typically whenever you're writing code, I'm not sure how many startups do write unit tests. Early, like the startups that are starting, they usually avoid it. But if you grow, eventually you will add unit test cases because the code base is growing. You'll have to make sure that it doesn't breaks, like any of the new changes do not break production, and for that unit test cases are very, very important. That is where you can easily test it. Why? Because every class will be a standalone class, so you don't have to test a lot of things. There would hardly be a single functionality and you can test it easily. But imagine if your class does a lot of things, so you'll have to test everything, and the bigger the use case, the tougher it is to write unit test. Get that into your head. Perfect. Next one, low risk in changes. Even if you do a change in a class and it breaks, you know that that change in that class caused the break, so you are aware if there is a break. And typically, because it's a single responsibility thing, you'll have to take care of that responsibility only. You'll not have to think about the other things. Got it? Reusable modules. What do I mean by that? So I can say, when I am saying that reusable modules, this is a code run with test cases. I can maybe reuse this module. Where can I reuse this module? Maybe if this is a class where they're getting the test cases and they're running the code. Imagine tomorrow if I build a IDE, and in that IDE, the user has to write the entire code. When I say entire code, it means the main method as well, along with the functionalities, along with the include and everything, import statement, everything the user has to write. After that, I don't need to add the driver code. Do I need? No, I don't need. All I need to do is a syntax check and a code run. I can just use these two classes and I'm done. Now, because it is an IDE and typically we don't store summations, so we don't need this, and maybe we need this. So you can always reuse the modules because every class has a single responsibility. So you can extract that single responsibility and use it in different places. Got it? That's a very simple use case, because typically in an IDE, you write the code and you hit the run button and it runs. So perfect. We know what are the benefits of SRP now. On a longer run, it does help a lot. What are the common mistakes when you're violating SRP? Let's understand that now. First of all, a lot of times I've gone through code bases and I see that a lot of people would put the DB logic, like storing into the database or maybe reading something from the database, and the business logic in the same class. And you should not be doing it. This is something you should be avoiding it. For database interaction, you can have a separate class. You can have smaller functions which you can literally trigger to do these kind of things. Avoid coupling them together. That is not recommended, because with database, there might be a connection issue. There might be something else. It's better to give that responsibility to a separate database class. Similarly with business logic, the business logic can fail. And why are you coupling that with database? Doesn't make sense. So always have the business logic in somewhere, and you can always call the database class to do the database thing. The UI code coupled with logic. Again, same mistake. We write the UI code, and at times there are a lot of logic that we integrate into UX as well. And if you're coupling them together, again, readability becomes a severe issue, because someone who's reading through the UX is like, okay, what's happening here? But if you would have separated that code into a class, defining what the responsibility is, it's easier to read. Okay, this class does this. Maybe I can give some comments and I can easily read through it. So it's very important you do not couple the UI code with logic, because tomorrow if you're changing the UI, it's gonna get messy. So it's better you have the logic in a separate entity. Perfect. So now we know about common mistakes as well. Last question, hey Striver, is SRP just for classes? Again, this is something you define as a developer, right? SRP can be defined by you, and it could be different for someone else in your team. I can define it for classes. I can define it for functions as well. I'll say a function should only be doing one thing. I can define it for like microservices as well, where I say that, okay, this is a microservice. It's going to deal with only one thing. When I say one thing, it means, let's say, my internal backend. Internal backend means the customer dashboard and everything. I can have a separate backend for that as well. So depends on what level you're defining the responsibility. Like in the TUF plus compiler, I defined responsibility in very granular levels. You could have said that, hey, run is a responsibility. Hey, submit is a responsibility. This is something that is defined developer to developer, depending on your use case and your product and your code size. So keep that in mind and decide accordingly. So that was about single responsibility principle. That was the first one. We still have 4 to go. So yeah, this is it for this one. Let's meet in the next one. Thank you so much for watching.